Well, how big is air pressure? I feel like I want to say, how heavy is air pressure? Is that right, though, Matt?
Well, it's the same thing, because the reason we have air pressure is because the weight of the atmosphere above us is pushing down. It's like when you're in a swimming pool, when you dive to the bottom, you feel more pressure pushing on your ears, right? It's exactly the same thing. We're in the bottom of this huge swimming pool, which is our atmosphere, and the pressure down here is higher than it is up at the top.
And in case you're wondering why we're discussing this, it is Wise Guy Wednesday on the morning show, and joining us, Matt Sellin, our favorite science guy, and you're going to help us understand air pressure now.
Yes, I'm going to show you a very cool trick. Now, are your pants splash-proof?
Probably not, but I'll sacrifice these.
So you can do this at home. All you need is some water, and I put a little blue food coloring in the water, and a little sheet of plastic. This is just from a transparency. If you pour some water in a glass, like this, and get it totally filled, and then I take my piece of plastic and just lay it on top.
Oh, yeah.
Now,
ooh.
Isn't that neat? And the reason this stays there is because of atmospheric pressure. There's 15 pounds per square inch pushing on all sides of this thing, so it's pushing this piece of plastic up. It's pushing the water upward. You could, in fact, have a column of water 33 feet high in this glass. This could be an enormous tube, and the weight of the water would not cause this thing to fall down. It's just due to the atmospheric pressure.
So is the air pressure the same inside the glass?
Well, it's just water inside the glass, and so the air pressure on the outside is balancing the weight of that water.
I guess.
So we can do this with an even taller glass. Now, I got in trouble with my wife because this is something out of our china cabinet, and the Wise Guy is not supposed to go in the china cabinet, I was informed.
Oh, compliment on your attractive stemware.
Right. But we're going to try this with an even taller glass, and we're going to see that it works here too. Isn't that cool? Ooh. And it's not surface tension. It's nothing like it's just air pressure that keeps this thing in there. And so this tells us that you can, well, that air pressure is big enough to hold up this big column of water. And in fact, you can make a barometer this way. Here's how you make a barometer. Well, this is how you would start. If you take a little tube like this, you fill it with water totally, you flip it upside down, and you see that the water stays up in this little test tube like that.
Okay.
You could have this thing 33 feet high. Once you got above 33 feet, which is as hard as the atmosphere can push water up, or as far as it can push it up, you would see a little space developing. Okay, and depending on how high that was, you could measure the air pressure.
Now, a question I'm sure a lot of people are thinking, if we've got 15 pounds per square inch pushing down on us, why don't we all get squished?
We're used to it. Besides, our bodies are filled with liquids, and so that we have the same pressure on the inside pushing out as on the outside pushing in.
Okay.
And so now, lastly, let me just, because this is something that you'll appreciate, this is a barometer. Over
nice
here,
one too.
Yeah, so we know that air pressure can support a column of water which is 33 feet high. Mercury, which is the stuff in the bottom of this device, is about 14 times more dense than water, so that air pressure can only support a column of about 29 inches high. And so the way you can measure, and the way that people do measure atmospheric pressure, is you have a tube just like this test tube, which is about 33 inches high or so. You turn it upside down after you fill it with mercury and stick it in a pool of mercury, and you just see how high it comes. And if you look up on this thing, at the very top here, you'll be able to see that it comes up to about a bit over 29 inches today.
As the air pressure fluctuates, it makes the mercury rise and fall.
As the air pressure gets higher, it pushes it up higher up the tube. As the air pressure is lower, the thing falls down a little bit. And if the air pressure was zero, the thing would go all the way to the bottom.
Okay, you've got a microwave oven on a stand over here. That leads me to believe that our next segment's going to be fun.
Oh, yeah. We're going to heat something up, and you're going to help.
Okay, well, we'll stick around for the next segment of The Wise Guy. Still ahead on the morning show, we're going to be riding the rails in today's Wish You Were Here segment.
Plus, don't let us sock